there we go. Somebody else got it. Thank you so much. All right, so we're up to 21 participants, seeing a number of familiar names and some new folks. Fantastic. Welcome to those of you who have not joined. This is the Earth Science Information Partners and USGS Community for Data Integration Information Technology and Interoperability webinar series. My name is Dave Blodgett. I'm your usual host, and am actually going to be doing the presentation this time. I'm actually going to be filling the role of someone else on this presentation. This has been given to a couple of audiences internal to USGS, and Alicia Rhoades has been the primary presenter with Ellen Brown, who will also kind of co-present with me. So Alicia and I, Jesse Ross, Diamond Holloman are from the water mission area within US Geological Survey, and Ellen Brown is with the ecological mission area, National Climate Adaptation Science Center. So got representation from a couple of parts of the USGS, and mostly focused on ecological modeling data or environmental modeling. We have for you today is about a project that we did for the USGS Community for Data Integration that I thought would be of interest to you all. And this is not too far from some work that was done by some work that we heard about in a previous IT&I presentation from EarthCube, the EarthCube Model Data Research Coordination Network. So if you didn't catch that, it was recorded a year or a little more ago. It's on YouTube. Really good material, and was kind of inspiration.
You might turn your camera off because
Folks who aren't. Oh, am I freezing? I'm going to turn my video off. Okay. So for folks who are not super familiar with USGS, there's kind of two worlds of publishing within USGS. One focused on software, one focused on data, and the two worlds don't necessarily integrate. And the big question that we were looking to address is there a formal integration that we should be pursuing, or should we be evolving the two ways of putting information out publicly that just integrates the two better, right? That was kind of the basic question. So we put together a community for data integration proposal and jumped into this project that we're about to present to you. So I'm going to go ahead and get going. All right, so the central project that we wanted to understand was that USGS Fundamental Science Practices, which is the governing kind of the governing practices that we as a federal science agency follow to guide our kind of work, considers data and software as two separate information product types. And in practice, data are often coupled to code, and workflows are often treated as software with data included. And we, basically that separation can be a strength, but that separation can also be very difficult to communicate about. So through this project, we assembled a team of pretty diverse backgrounds to try to understand employees' feelings as much as anything about current practices and policies, and try to start to understand where the consensus opinion was or is about where to take the integration of data and software. So the methods for our project were inspired or really guided by Diamond Holloman as a social scientist who assisted us in really building the design for the project. And it used this social science approach called triangulation. And so that refers to kind of multiple methods or data sources in qualitative research, where we can develop a comprehensive understanding of a topic. And so we utilized this idea of empathy interviews, and the goal there was to understand people's feelings about data and software releases, and the process that they go through to publish data and software. And the data from those interviews were analyzed using this qualitative method of coding data. So the coding is basically just tagging responses from people with particular categories that are observed in those responses. So then to investigate patterns in how the data and code are released, we examined, so that's kind of in the second component of the project, we examined data releases in the system USGS uses called ScienceBase. And that basically looked at a set of data releases for a year worth of science data publication. And so we scraped that all out using basically an R workflow. And then finally, we randomly selected 200 software repositories from the 508 public software repositories that have been published as official software releases, and basically just scanned those, mined them for the information we could glean from them. And then the third method was our own observations, right? Where the researcher in the loop was a part of this, and so our own interpretations, both qualitative and quantitative, of what we saw between the empathy interviews and the data we were able to glean, formed this kind of triangulated set of outcomes. So getting into the specifics of what we did in terms of methods, we had a pretty broad group of people that we interviewed. 85% of them had written some code. 60% of them had written code-based workflows. 56% considered their workflows to be quote unquote reproducible, although the definition of reproducible varied. Similarly, 56% were active in code.usgs.gov, which is the USGS's GitLab instance for official software releases. 36% had completed an official software release. And official meaning it's a citable piece of software according to fundamental science practices. And only 12% considered themselves software developers. And just a little bit of an aside, I was pretty amazed, and I shouldn't have been amazed, but it was remarkable that we had 85% of our respondents who had written code, and only 12% of them who thought of themselves as software developers. And that gap is kind of telling. So definitions, shared definitions, lack of shared understanding, support and resources. So basically people feeling like they did or didn't have the support and resources they needed to traverse the release process of software and data. The review process itself, so USGS has a pretty robust internal scientific review process that's prescribed by fundamental science practices, and that process is definitely cumbersome at times. The human and social dimension, so there's a lot of there's a lot going on in the process of getting technical software and data releases published that may or may not be things that people are confident about. And the expectations that people have, the relationship they have with their peer reviewers and their approving officials, which are essentially their supervisor or the director of the office they work in, and even higher, there's bureau approving officials that are responsible for ensuring we follow fundamental science practices. So there's a lot there, and then finally systems. We've got these systems we use to publish data and software, warts and all, right? Where they're empowering, but they also hold us back. And there's a fair number of findings in that space. And I'm gonna try to slow down here and make sure I'm not getting off the track too much. So findings in terms of definitions, essentially this idea of a lack of uniform understanding of terms that we use in our best practices. There's a lot of there's a lot of diversity in people's working definitions across the organization, and so different centers, different offices might have people that have different working definitions of some terms. So examples: code, model output, scientific software, reproducibility. Different working definitions of those words lead to very different practices. And so without like a standardized definition of code, it's really unclear from the scientist's perspective or the software developer's perspective what review steps need to be taken to release that code as software. Or if code is included in a data release, how does that apply in a review context, right? And so there were a number of examples like this, but this is a kind of a good one to pull out and just to illustrate that it's very hard to have these shared definitions across the board. And there are some in particular that are more problematic than others, and that we found some opportunities probably to refine guidance or refine policy to help people have a more firm understanding of what the expectations and practices are for them. So findings in terms of support and resources, this by and large, the resources available to support data and software management, when they're limited, can feel like they create barriers to the release process, and that was fairly broad, fairly broad held kind of opinion that additional resources would help lower the barrier to getting software and data out the door. And having more people with advanced technical skills and that additional training required would be a big benefit. So with regards to the review process, the long and frustrating reviews were not the norm, but fairly common. Basically finding, and so with software and data in the USGS, there's no journal editor to find a peer reviewer for you. It's up to the author and their supervisor to identify the technical reviewer that's appropriate. And that, finding that person who has the domain knowledge, technical proficiency, understanding of the policy that it applies to the review, all
I lost you for a second.
Am I still here?
You're there.
Okay. So the common feelings were that people were typically kind of overwhelmed or reluctant to push forward in areas where they didn't really have the expertise they needed or didn't really understand the process. And that was really where data stewards or people available to help with software review seem to be the most valuable. It's basically giving people the support they need to get started, to understand how they would even start in a process of review and approval of the technical work that they've done. And this was something it's a really challenging one. It really requires you to kind of empathize and understand where the person's coming from. to even understand how you would help. And because it's not just a training issue, it's a what are people struggling with so that we can train the correct things to make people more successful. And so this area, I think it's probably especially true and hard outside of some of the professional settings like we have at the USGS, like in academia, helping grad students be successful at getting their reviews done is tremendously important and difficult. And it's no different within the USGS. And then systems was one that was actually pretty, we have some pretty specific opportunities, I guess. The, you know, the systems that we have, I think there was one quote in particular we pulled out was that the systems leave an awful lot on the table. The existing systems get their core job done, but they don't integrate with each other very well. And they don't offer very many of the kind of key value adds that people would like to see in terms of integrating software or workflows into a data release and having the data release information product have direct integrations or direct references to the way the data were produced from a reproducibility point of view. And so like that would be one example. And then on the software side, the software repositories they very much discourage inclusion of data in the software. And there's no real formalization of how to point to data that's important to a given piece of software. And so those kind of linkages were things that people really called out, and the opportunities to make those connections are not obvious, but they're more apparent than some of the other findings that we had that are definitely a little bit less concrete. So with that, so do I pass to
That's
you
me.
here, Ellen? Yeah. Okay. So now we're going to pass over to Ellen to take us through the rest of the slides.
Thank you. So I'm a data manager at the National Climate Adaptation Science Center with the USGS. And so I really want to see these improved because it really helps in my position to help scientists move through these processes. So the next part, Dave just kind of went over the findings and the methods from the interview component. And we're going to shift now to kind of our findings from code.usgs.gov, which Jesse Ross, who is here, worked on this part. But I'm going to run through it for us. So to complement these qualitative interviews and establish the baseline for how USGS releases containing both data and code are structured, we examined these two main USGS repositories. The first one is the code.usgs.gov, which is the GitLab instance for USGS. And it's the platform for releasing the scientific software developed by USGS scientists. So 200 randomly selected repositories out of the 508 total in the USGS Project Explorer. And that's the comprehensive listing of our published software in code.usgs.gov. And an R package was used to download and examine the size of those 200 selected repositories. And the largest 10% of these were inspected manually to determine whether data were present and if any unique structures emerged. And so of those 200 repositories, 188 or 94% were less than 1 gigabyte in size. However, the larger repositories were quite large and exceeded 20 gigabytes, which is most often indicative of data being packaged within the repository or of special cases that seem to deviate from the norm. We found that despite recommended practice of not packaging data within a soft release, the data have been packaged in code repositories for specific purposes, such as sample data for generating figures or unit testing. In some cases, it may be more appropriate to include instructions on how to access the data elsewhere. However, other repositories containing original data may have needed the data for functioning of the software. Another finding was that several of the largest repositories may have been smaller if better software release solutions were used. For example, one repository had more than 90% of the total size taken up by a number of historical versions of installer executables. So maybe it could have been formatted differently, and that would have improved the size allocation. So in general, we found the form and content of repositories to be relatively uniform in scraping or mining code.usgs.gov. And because scientific software releases at the USGS must be released through code.usgs.gov, and working with GitLab does require a technical skill set, we found that these published software releases generally follow best practices that are appropriate for Git repositories. However, it's important to remember that this component of the findings evaluated software releases that made it through to completion, and the survivorship bias may be a strong factor here. Next slide. So the second database that we looked at was Sciencebase. It's a USGS repository meant for, this is a primary repository for releasing data. So while it is not best practice to release data within a code.usgs.gov release, there are situations where it is acceptable to package data and code together in Sciencebase, such as when code or scripts are used for the documentation of a data set with model inputs and outputs. So we surveyed the Sciencebase repository to better understand the occurrence of code being packaged with data. And to do this, we used an R package to generate a complete list of files for each item, then looked at the file extensions of of the commonly used languages like R and Python, Fortran. And then for files that had archives, we downloaded all archives less than 30 megabytes and listed the contents. So of the 2,589 USGS data releases from a one-year period that were examined, 126 of these, or 4.9%, contained code, either within archive files or as direct attachments. So code or software can be useful as documentation for ensuring that data provided in a release are reproducible or reusable. The most common examples of code released in a science-based data release were scripts used for the creation or validation of data sets, usually as R, Shell or Python scripts or notebooks. Another frequent cause for inclusion of code was providing zip files of dependencies as part of a download. So from this analysis, we were not able to determine the level of review completed for code embedded in the data releases, where we have this really strong review structure for the software that goes into code.usgs.gov. We were not sure what level of code was, or level of review was completed for the code packaged with data releases. So the format of data releases containing code in Sciencebase were mostly consistent. That either the USGS data release policy or the model application archive structure, which is a specific set of guidance, guided setup for most of these data releases that we found containing code. A model application is a data set with rich documentation, which often describes an inclusive workflow, such as when the data set has inputs, ancillary content, and outputs. Next slide. Okay, so as far as synthesizing this work, it's important to recognize that the quantitative methods, reviewing the repositories for what is actually done, how things are structured, those examined only published data or software releases, while the qualitative interviews captured the complete release process from project planning through to publication, or in many cases, it provided insight as to why information products had not yet made it through to publication, which could be, the review process, or the different themes that emerged from the interviews. Different reasons and challenges that we found. Across the different roles of interview participants, so from those who are responsible for approving information products, like such as supervisors or center directors or the bureau level approval, to the scientists to data managers, it was recognized that linking the software and data is not a common practice, which presents an obstacle for discoverability and reproducibility. Particularly, it was noted that the USGS tracking system, which supports the linkage of information products, such as publications, software releases, and data releases, does not support the relatability to external releases. If a USGS author was on a publication but not on the data release, there wasn't a way to connect these items. A final key point is that advanced technical skills would improve the technical soundness of software releases or situations where code are released with data. This could be achieved through multiple pathways, such as enhanced collaboration between skill sets or establishing a dedicated team of reviewers who have the technical expertise. Next slide. So we wanted to talk a little bit about next steps. From this project, we did not seek to make firm recommendations from this project or develop concrete solutions. However, some actions were identified that could improve current processes for releasing information products which generate both data and code. And these actions include the development of a decision tree or checklists for the release process, establishing a standard mechanism for linking data, software, and publications, kind of as a whole package. And also building training modules for software and data reviewers, and making sure that all USGS centers are supported by a data manager who can guide or shepherd the releases based upon a process that is consistent with other science centers, with other USGS science centers. And so our next step will be continuing to share the full internal report. We have a spreadsheet of our interview responses, coded and de-identified. And so that is kind of an internal appendix to our full report. And we'll be sharing the internal report with others in the USGS who are working to improve policy. We also recommend the organization of a community for data integration workshop at the spring 2025 in-person meeting. There's a wider stakeholder group. A wider stakeholder group can work to make recommendations and consideration of this evaluation and synthesis. So I'm going to take a sip of water. So the USGS Office of Science and Quality and Integrity, they oversee policy development to ensure that USGS programs and products meet a high level of quality and integrity. And so another next step, we do coordinate a seminar with the Office of Science, Quality and Integrity and other interested USGS staff to further integrate these findings into related efforts and address these questions and challenges that we identified throughout the project. So there's a whole lot of interview nuances that came out from the participants. And Alicia has a lot of insight there. And so we wanted to thank all of the interview participants and thank you to the community for data integration for supporting this work. The next slide. Yeah, and we're happy to take questions and are interested in insights from this community as well. Thank you.
All right, I'll come off mute. And so thanks for taking us through that, Ellen. And yeah, Alicia is off celebrating her birthday. So kudos to her. She probably would have done better justice to the intro slides, but hopefully I gave everyone a reasonable overview of kind of where we were and what we went through in the project. And yeah, I guess the only other before we open the floor to discussion, and I'm curious if folks have questions or want to discuss any topics here. The this report, the report we brought together, and the overall work is very internally focused within the survey, and it's basically because we're working on internal science policy, science review policy, publication, basically publication of official government project outcomes. And we were a little hesitant to present to this group because of that. It's more or less relevant to any of you. But I hope this was a valuable kind of perspective on some of the internal deliberations and how that works within the community for data integration and within USGS. And I also hope there's some analogs here that could kind of benefit folks and yeah. So I'll stop there and would be thrilled to field questions or discuss anything you heard that you had questions about. And if there are USGSers in the audience that would like links to things or anything, just reach out to Ellen or I. We're happy to connect you to things that are only available within the network. See Rob Casey, go ahead.
Yeah, thank you for the presentation. I was wondering if you could speak to how this effort within the USGS connects to the use of persistent identifiers and the metadata that's associated with those persistent identifiers for the purposes of publication and citation.
Absolutely. Yeah. So there are two. So USGS data releases and software releases can both be made in a form that we call provisional. A provisional release is one that we would not mint a persistent ID for. And what we've been talking about is, and this is actually I think this is a really nice opportunity to talk through this, so thank you. What we've been talking about is the process that we have to go through as civil servants to be allowed to be reasonably eligible to mint a persistent ID for either a tagged software release or a static data release that's of known review quality, if you will. One of the big questions I had coming in here is, should we have a process that allows you to get a persistent ID for a combined software product and data product that is in some senses one digital object? And that's still kind of an open question. Is there a need to have a packaged information product type that we could get a digital object identifier for that combines these two things? So yeah, very, very much an open question. But why would you go through review? Well, because you need to cite your stuff, and to be able to cite your stuff, you have to have a DOI, and that's a lot of the motivation, the kind of core motivation to what we're doing here. So yeah, hopefully that kind of helps with a little bit more of the background.
Yes, thank you. Yeah,
okay.
That's good.
Rachel?
Yeah, thanks for that really great set of presentations. And just to reassure you that as someone sitting externally to USGS, I'm at the Open Geospatial Consortium, and this resonates very closely with some current work we're doing on exactly the problems of trying to make code and AP, so AP, particularly standards and API driven code available in a way that's reproducible and citable and more reusable. And I thought it was really interesting that you were trying to separate out data and code strictly. And so I wanted to ask you a little bit more about that. We also are considering the inclusion of small sample data sets for the purposes of essentially unit tests. And our project had seen that as a positive for supporting reproducibility because someone accessing a code repository could essentially have that sample data to hand that should work, be able to run the unit test, and then be able to kind of move on and reuse as appropriate, substitute their own data with a template in place. I could see an argument for putting the data as a separate entity and linking it, but I just wanted to hear a little bit more about what you heard from your users on that practice.
That's an interesting, it's an interesting topic. And I actually want to invite Jesse Ross to comment on that if you could, Jesse.
Would you mind just saying the question one more time? I think I understood, but I want to make sure that I'm answering it right.
Yeah, of course. So basically in a not dissimilar project, we're looking at archiving code, and we are looking at archiving small sample data sets packaged together with that code. And when I say packaged together, I mean with the same DOI, so that that sample data would be available for example, unit testing. And our logic was that this would improve reproducibility because you would access a single entity at a DOI that would have a script and sample data that would let you test whether or not that script was running correctly on the platform where you tried to implement it. And you were discussing a logic of not following that practice and separating out the data from the code. So I just wanted to hear more from you about what your users had said and what the thinking was around that.
Okay, yeah, thank you. So there's kind of two angles on that question. You know, one is kind of what makes sense from an engineering perspective, and one is what people do to try to comply with USGS Fundamental Science Practices. I think from an engineering perspective, it makes a lot of sense to include some sample data as part of a package. And, you know, you can use it for unit testing. You can use it as example data for any sorts of kind of vignettes or tutorial material that the software might have. That is common in USGS software releases. And I think that it is kind of supported by the, at least by my interpretation of FSP. So, you know, basically, I think that that's a great thing. The thing that we found was really causing a lot of confusion was when people had larger amounts of data that they wanted to be able to access from a software package. And, you know, we saw people including things like shape files that might be essential to the functioning of a package rather than just for the testing. And that starts to get a little trickier if that shapefile is its own scientific product. And then, you know, kind of on the other side, when people had data releases, you know, there was sometimes substantial software, substantial code tooling that was involved in creating those. And people would sometimes shoehorn that into the data release and sometimes not. So, you know, I think it really highlights the fact that it's the current guidances are hard to interpret, and we don't have a really good shared vocabulary or great shared understanding of what is allowed. But kind of zooming out from the USGS specifics, I think I would consider it to be a best practice to include some sample data in the way that you're describing.
Thanks. I really appreciate hearing that from you.
I had a quick follow-up to that. We did have an interview participant, or no, it was a question that came up, a discussion question that came up later it said they thought it was okay to include code in a repository for certain purposes. And so there is that confusion where there are recommendations from other groups within USGS that say it's not best practice. So there is, like Jesse was saying, there's confusion around that.
Yeah, it's whether it's toy data or real data that's important to your software's functioning, it's often pretty squishy as to whether you should publish it through a data publishing platform or a software publishing platform. And the formalisms for the combined software and data product are pretty few and far between. Any other questions?
Hi, it's Rachel again. If I can sneak in with one more, I'm really curious with your user community, if you ask them what they felt as an individual, the value add was to them of doing all of the work of making their code, making their data ready for deposit. So you mentioned citability, so the need for your materials to be cited. But if you were to pick between increasing its reproducibility, being able to maintain transparency in workflows, so we can think of kind of other FAIR-esque properties, were there any things that came up in interviews frequently or stood out to you?
I can jump in with a start on that question. We did talk with interview as part of the questions that we asked, or what would incentivize you to release? You know, what is your incentive? A lot that came up was because the culture is like citations. So they're evaluated based upon how much they publish. And so being able to get to that point of having a DOI and having this gets them towards that goal. A lot of focus was on publications like journal articles and having to do it as part of that process for their evaluations. And so there were some who wanted to do it to make it available and reproducible, and really excited when other people did that too, because they could share it. But others seemed more hesitant about the process and did it. Their incentive was because it was a requirement of the journal publication. Dave, I don't know if you have anything to add to that as well. If that answered the question.
Yeah, I mean, it's there's a lot of anxiety around this for some projects because it's not always clear so within USGS, a lot of times we say like, does fundamental science practices require that I do X? And the interpretation of require to do X is kind of, it's like interpreting, I mean, it's very much a professional interpretation of your own work relative to a set of rules that are written in a very general sense. So the value is often that, well, to release this information, which is in our world, the information we release is not our own intellectual property. It's the official stance of the U.S. government once it's been released in a formal way. There's a lot of the reason that we do the reason that we would go through these processes are because we have to. And there's, that it's hard, that's the stick. And then there's also the carrots or the incentives that are more proactive about your work later is going to be easier. Your next review is going to be better because your next personnel review is going to be better because you've accomplished something that you can tout as a citation. It's a mix of those two things. And yeah, but I think that's probably pretty similar to elsewhere. You've got your policy context and you've got your kind of professional advancement context, and the two are kind of intermingled. So, and I guess I'd be curious if for folks from other organizations, especially other federal agencies, I know the USGS has a in comparison, pretty mature fundamental science practice policy baseline. But I guess I'm always curious to hear from other federal agency staff about these issues in their day to day. So if there's anybody that wanted to comment on that topic from other agencies, it'd be great. If not, I honestly don't know who else here. So
Rachel, were you going to follow up on anything as well? I thought I saw you come off mute.
No, I was just going to say thank you for answering.
Thanks.
all right. Well, if there's nothing else, we'll give everybody 10 minutes back. Thank you so much for coming along. Apologies for slightly flaky internet and no video, but that's the way it is. Hope everybody has a good rest of the day, rest of June, and yeah, be in touch if you have questions or follow-ups, you'd like more information. Happy to field questions via email or otherwise. And otherwise, next month is all lined up. The invite is out for that, and it'll be an update from Brianna. I'm going to butcher her last name. I believe it's Pagan. But Brianna's going to come and give us an update on ongoing work on the in development GeoZar standard that is an Open Geospatial Consortium standards working group activity right now. So very much looking forward to hearing about their progress and where that work is at. So other than that, after that, we'll see everybody at the ESIP summer meeting. Looking forward to being there later on in July. So with that, have a good afternoon. Take care, everybody.
Thank you.